Okay, so for problem number 1, keep in mind that these are all just going to be problems where the object is being dropped. Notice how I said that they're being dropped. They're not being thrown upwards now. They're not being thrown downwards. And we'll actually see that in these problems over here. So problem number 1. Your sister drops your house keys down to you from the second floor window. If you catch them 4.3 meters from where your sister dropped them, what is the velocity of the keys when you catch them? Okay, so it's describing here that your sister is dropping keys out of a window and they're dropping for a total of 4.3 meters. And you're being asked, what is the velocity of the keys when you catch them? What I'm just going to do here is I'm just going to draw a picture. Does it really matter that they're being dropped out of a window? Does it really matter that they're being caught and not actually hitting the ground? No, we just know that they're dropping for a total of 4.3 meters. So we essentially, well, what do we have here? We have an object. It's going to be dropping for a total of 4.3 meters. I know that I'm showing here that's hitting the ground, but it doesn't matter if they're being caught or if they're hitting the ground. We know that they're dropping for a total of 4.3 meters, and that's what matters. Okay, so this being the case, just think about the situation. Your sister, what is she doing? She's dropping keys, and they're dropping for a total of 4.3 meters. We're trying to find out the velocity of the keys when you catch them. They're going to hit your hand or hit the ground at a certain velocity. That's the velocity that we're trying to calculate here. So let's pull out some given information. What would you say is the initial height of the object? Well, we're given that. That's given information here. It's 4.3. And what would you say is the final height of the object? Well, it's being caught, it's hitting the ground, so it's dropping for a total of 4.3 meters. We could say that the final height is 0. Let's come over here. Let's just start writing this in. What is the initial velocity? Am I throwing these keys up? Am I throwing them down? Or am I just letting go of them and letting them drop? Initial velocity is 0 meters per second. What's the final velocity? Oh, isn't that what we're trying to find? What is the acceleration of the object? Once again, for objects that are in free fall, is going to be a negative 9.8 meters per second squared. That's acceleration due to gravity. And are we given anything about time? Are we being told anything about time? No, right? Oh, so we're going to treat this just like we actually treated the previous problems. So we're going to say, what do I not care about? Time. I'm just going to come back over here and let's look through these. I'm going to tell you right off the bat, I don't think that I actually have any problems for free fall that actually have to do with average velocity. So I'm just going to erase these two equations right here. It's going to be these 4 equations that we're going to be mainly dealing with. Now, once again, what did I say? The variable that we simply just don't care about is going to be our time. Let's come through here. Let's find all the equations that have to do with time and exclude them. So we have time right here. Okay, that's an equation that we're not interested in. Coming over here. Oh, we have time right there. Okay, so I'm not interested in this one. What about this one? Oh, we have time here and we have time there. So definitely not going to be using this one. And do we have time in this equation? Nope. Okay, so we're going to be using equation number 6. Make sure that you write it out correctly. And did I do that correct? Let's just double check here. And that looks good. Okay, so now let's plug in our information. So we have VF squared is equal to VI squared, which is 0 squared. 0 times 0 is equal to 0, so that's not going to have any sort of impact. 2 times our negative 9.8. Then we have our final height, which is 0, minus our initial height, which is 4.3. Okay, so this 0 squared, 0 times 0 is equal to 0, so that's not going to have any sort of impact on our equation. We have this 0 over here, and 0 minus 4.3, or we could actually just call this a minus 4.3, a negative 4.3. They're the same thing, it doesn't really matter. So let's just get rid of this 0 over here, and notice here that what we have is 2 times, well, it's a positive 2 times negative 9.8 times a negative 4.3. So we have a positive times a negative times a negative. This should result in a positive answer. I'm just going to toss this in the calculator right now, and we get 84.28. That's equal to Vf squared. I don't care what Vf squared is equal to. I want to know what our final velocity is equal to. So how do we get rid of the squared? Take the square root of both sides of the equation, and we get Vf is equal to 9.2 meters per second. Hey, wait a minute. The answer over here is telling us it's negative 9.2 meters per second. The calculator, when you take the square root of this, it will not give you a negative answer. It's going to give you the positive version. So make sure that you do include the negative to account for the direction.